Okay, geometry students, on to our next topic. It's 11.3. Okay, chapter 11.3. It's on starts on page 610. The title is Areas of Polygons. So we've done areas of triangles, areas of circles, area of rectangles and squares. Those are the most basic and common. This chapter is going to touch on areas of non-regular polygons. What I mean by that is not squares, rectangles, circles, or triangles, okay? We're not going to spend a lot of time on this with what we have left in school, but I want to at least touch on it so you're familiar with it, okay? So again, page 610, finding areas of rhombus and kite, okay? And here's an example of a rhombus and a kite. The difference is a rhombus has all four sides equal. It's kind of like a diamond, all right? Think of a rhombus as a diamond. All four sides equal. A kite is similar to rhombus except for two of the sides are equal, but they're different lengths than the other two sides. That's a kite. It makes sense. You guys, I'm sure, know what a kite looks like. Typically, when you fly a kite, the top two sections are shorter, the bottom two sections are longer, but those top two sections are equal, and the bottom two sections are equal. So that's a kite. The one where all of them are equal is a rhombus. Think of it as a diamond, okay? So, here's your core concept, the area of a rhombus or a kite. The area of a rhombus or a kite with diagonals D1 and D2 is equal to this formula. 1/2 D1 times D2. That's all it is. 1/2 this diagonal times this diagonal. That's as complicated as it needs to get. Where did I set my eraser? Put it back away. Okay. So it gives us some examples to look at. All right. For calculating the area of a rhombus and a kite. Find the area of each rhombus or kite. So in letter A, clearly we have a rhombus. All four sides are equal. It gives us the diagonals. This one is 8. This one is 6. The formula 1/2 diagonal 1 times diagonal 2. I have 1/2 times 8 times 6 equals 24 meters squared. Okay? That's all it is. That's the area of that rhombus. This kite has a diagonal here of 7, and this one's 10. So I have 1/2 times 7 times 10 equals 35 centimeters squared. Basic concept, okay? Just remember the formula, 1/2 diagonal 1 times diagonal 2 for rhombi and kites. I bet you we have some checking progress problems down below here. We sure do. Monitoring progress numbers 1 and 2. Please pause at this moment, pause, and solve for 1 and 2. Okay, so number 1 says, find the area of a rhombus with diagonals D1 4 feet and D2 5 feet. So your formula, 1/2 times 4 times 5, which is 20 times 1/2 is 10 feet squared. Okay, and number 2, find the area of a kite with these diagonals, 12 inches and 9 inches. 1/2 times 12 times 9 equals 54 inches squared. Okay, that's all the heart of that is. This is going to be a very easy section. All right, that's the area of a rhombus and a kite. All right, coming up on a new vocab word, yay! And I can tell you until I started teaching you this, I had honestly never heard of this word. Must not have been around when I was young, many, many moons ago. The word is apothem. Apothem is one of those little creatures that runs around in the forest and hangs from its tail. Apothem. Sorry, that's a terrible joke. Apothem. A-P-O-T-H-E-M. This is going to be a very introductory, so you have heard it and know what it is type of situation. An apothem. Okay? So, in this example, you have a hexagon, a regular hexagon inscribed in a circle. What that means is this: if it's called a regular hexagon, it means all sides of that hexagon are equal. It's like an equilateral triangle. It's an equilateral hexagon. The word regular means equilateral, okay? So we have this equilateral, this irregular hexagon inscribed in this circle with a center here of P. So you've got these two lines drawn out to two different vertices adjacent to one another, M and N, okay? In addition, you have this blue line. Let me do a different color. This blue line going to the side of the hexagon. Okay, that line is the apothem. You know it as the height. When you think about this, if I were to rotate this and redraw it like this, okay, I have a triangle. And because it's two radii, it is an isosceles triangle with this apothem coming down here forming the 90-degree angle. That's the hypothem. Not hypothem, apothem. All right? It forms the height of the triangle. So clearly, if you knew the distance for the apothem and the distance of the base, you can calculate the area of this section. Okay? That's all that really matters. So that is the word apothem. And of course, you can also have this is called the central angle that it forms right here. MPN forms a central angle right there. Okay, so let's see what the example wants us to know. Again, we're just touching on this. We're not going to get complicated. Later in this chapter, things can get complex, so we're not going to worry about that. Finding angle measures in a regular polygon. What kind of polygon do I have in this example? That's right. Good job, Solomon. It is a pentagon. 5 sides. It's a regular pentagon, which means all 5 sides are equal. So here it says, ABCDE is a regular pentagon inscribed in circle F. Find each angle measure. Now, what I need to talk to you about is, as it forms this angle here, okay, BFA, it forms this inscribed angle, or AFB as it says. How big is that angle? Well, this is a pentagon. This angle forms one side of that pentagon. A pentagon has 5 sides. And this angle forms one of those 5 sides to go all the way around the circle. So if I want to know the measure of this angle, because it's a pentagon, I divide 360, which is the measure all the way around the circle, divide that by 5. Okay, so that angle is 72 degrees. AFB is 1/5 of the entire circle. It's 72 degrees. Great. The next, letter B says, what is the measure of angle AFG? AFG, which is the angle formed by the apothem. Because this is an isosceles triangle and that apothem forms a 90-degree angle on that triangle, it splits this angle in half. So we determined it was 72 degrees right here. So then that apothem cuts that angle in half, divides 72 by 2, and you get 36 degrees. Okay? Then lastly, measure of angle GAF. So, here's what we know. Let me get a different color. I'm having so much fun with colors. So, GAF, this angle, the last angle known. I know this one's 90. We just calculated this one's 36. So I add those together, 90 plus 36, and I get 126. I want to solve for the third angle of the triangle. Remember what I've told you, the most basic thing to remember of all triangles is all angles add up to 180 degrees. So I can take 180 minus 126 and I get 54 degrees for letter C. 54 degrees. So that's what the apothem does. The apothem slices this triangle in half at the angle because it's isosceles. It forms the height so you can calculate area if you know that base, and then you can calculate the angles of the triangle. All right? Apothem, A-P-O-T-H-E-M, yay! All right. I think I have one more thing I want you to know. Let me get this cleared. Oh, before I clear it, sorry. Well, before I go on to the next topic. Monitoring progress, yay! Hey, before I do that, I haven't told you a joke yet, have I? A dentist and a manicurist had a very rough marriage because they fought tooth and nail. A dentist and a manicurist, they fought tooth and nail. Someone explain that to Brandon, please. What do you call an Irishman who bounces off of walls? Rick O'Shea. Rick O'Shea. Ricochet. All right, there you go. It's the best it gets. Okay, so let's go ahead and pause, please, and solve number 3 and 4. Okay, so number 3 says identify the center, a radius, an apothem, and a central angle of the polygon. All you're doing is naming them. Very simple. The center of this figure is P. Okay, center equals P. A radius, well, you've got 2 options to choose from. PX or PY, right? The radii are PX or PY. Okay, great. An apothem. Clearly there's one apothem from the center to the edge of the polygon, the square. The apothem equals PQ. And a central angle. This is the only central angle formed. Looks like XPY. Angle equals XPY, or you could call it YPX, one or the other. Okay, you're just identifying the angles. Okay, the second thing is where you actually have to solve for things. All right, let me erase that. So find the measure of XPY. I want you to find the measure of angle XPY right here. Well, this is a square, okay? So these angles are all 90 degrees all the way around. And this apothem cuts things squarely in half. So XPY equals 45 degrees. No big deal. XPQ. XPQ. Right there. Well, if XPY equals 90. Let me change that. XPY equals 90. This entire angle, XPY, forms 90 degrees because it's a triangle. I mean a square. All right. XPQ, because there's an apothem here, cuts that in half. XPQ equals 45 degrees. And PXQ. PXQ. If this is 90 and this is 45, then the other one also has to be 45. Okay? It is an isosceles right triangle, 45, 45, 90. And of course you remember that means that this is 1, 1, square root of 2. Okay, let me see, is that it? That I want to go over with you, I believe so. Oh, I do want to at least show you this formula. Let me erase this. A very simple formula for how to calculate the area of any regular polygon. Any regular polygon follows this formula. 1/2 the apothem times the perimeter of whatever that polygon is. 4, 5, 6-sided, it doesn't matter. If you can calculate the perimeter of that polygon, times it by the apothem, and times that by 1/2, that's how you calculate the area of that polygon. Okay? I'll go through this example to finish off. A regular nonagon is inscribed with a radius of 4 units. Find the area of the nonagon. Nonagon equals how many sides? Nonagon equals 9. 9 sides. All right, so we have to step back into some of our trigonometry. Trigonometry, okay? So, what that means is, let's think about what we know. If this is a nonagon, it formed this angle with 2 adjacent sides. So what is the measure of this angle? That would be 360 divided by 9 equals 40. So the measure of angle KLJ is 40 degrees. Now, I'm going to redraw this like I did the example like this. Just the triangle. L, K, and J. 4, 4. Here's your apothem. We know that this is 90. We know that this, half of this is 20. Okay? So I have this little triangle with 20 and 90, which makes this 70 degrees. What I'm trying to calculate is the length of this segment right here. Okay? So I have 20 degrees, 70 degrees, and I have the hypotenuse of 4. Okay, so I can utilize either sine or cosine to solve for that exact problem. Doesn't matter which one you choose. I'm going to choose sine. The sine of 20 degrees equals opposite, which we are solving for, over hypotenuse, which is 4. So I'm going to take the sine of 20 degrees and multiply it by 4. Give me just a second while I calculate it. 20 degrees, sine times 4. Okay, so we'll round it to the nearest tenth. This length is 1.4. That's 1/2 of one of the sides of this triangle. So if I times that by 2, the length of this whole triangle is 2.8. Okay, which is this right here. That's 2.8. Now remember our formula. 1/2 times the apothem times the perimeter. If 2.8 is one side, I have 9 total sides. So I times that by 9. I get 12.6. So I have 1/2, and my apothem is 12.6. My perimeter is 12.6. Now I just need to know what my apothem is. Okay, and again we got to go back to trigonometry. If I have 20 degrees here, and I go the cosine of 20 degrees equals adjacent, which is my hypotheme, over hypotenuse, which is 4. So I take the cosine of 20 times by 4, and I get my apothem of 3.8. This is 3.8. So now I fill into here, 1/2, 3.8 times 12.6, that's to get my area. And I get 23.9. Okay, 23.9 units squared. Now I haven't checked, let me see. Does the example agree with me or vice versa? It does not. What did I do wrong? Well, shoot, I felt so confident in myself. I don't know, I've got to look it out. Sine of 20 equals x over 4. And the cosine of 20 equals x over 4. Because the answer down here says 46.3, which is about double what I got. I'll look at it, we'll go over it together in class, okay? If you guys find my mistake, great. If not, I'll fix it come class time. I don't want to rewind. And it's getting very complicated, and that's all the further I wanted to go with that anyway, okay? So I'll look at it, see where I messed up. I'll correct it come Monday, or come Tuesday. Work it out for you as well. That's the most complicated we're going to get. We're probably going to stay mostly more basic than that. All right, guys, have a good day.